Okie doke, guys. Welcome back. Welcome back to the Ed Puzzle. Uncle Ed. We're going to just finish section 10.2. Okay, this should be pretty short. A couple different things to look at. So, let's just get going. So, we're going to talk about arc length. All right, so this is going to actually look different than what's on your paper because I've completely changed the whole thing. I thought of a better way to look at this, but so in any case, if you want, I can post this for you. So, all right, arc length is the distance between, we'll just say the distance, between two endpoints of an arc in linear units. Okay. So, arc length, we use this squiggly L, right, cursive L, and we want to find how long the arc length is. So it has to be a portion of the circumference. So the formula has to have circumference in it, 2 pi r, right, because it's some portion of it. So what portion? Well, it can't be the total circumference, or that would be 1 times 2 pi r. So that doesn't make sense. So we need a fraction, right? Because the arc length, especially in this picture, is some fraction of the total arc length, okay? So that's where the x comes in, right? So the x is an angle, let's say 60, right? But that's part of a total circle, right? 360 degrees. So that's where we get our fraction from. So it's one portion, right, of the circumference. So for example, if x was 90, right, the arc length would be 1/4 90 over 360, which is 1/4 times 2 pi r. So that would be 1/4 of the circumference, right? Which makes sense because 90 degrees is 1/4 of 360, right? The total angle measures, okay? So basically what we're going to be doing is you can just plug into the formulas here and figure out what the arc length is, okay? All right, so example 5. Find the length of arc ZY, okay? So I'm going to assume here that they're talking that this 10 centimeters is the diameter, okay? That's what it looks like. So again, all I need are a couple things, right? I need the radius, right? That was in the formula. I need the central angle, which is 130. That's x. So that's what I'm given. I want to find the arc length. So the arc length is already solved for in my formula. So this is just going to be an easy plug and chug. So L equals 130 over 360 times 2 pi times 5. So I get 13 over 36. I'm going to simplify that times 10 pi. And then I guess you could keep simplifying, but we'll say 130 over 36 pi, which equals 65 over 18 pi centimeters. So you could plug that in a calculator, right? I'm just showing you what it would be if you left your answer as pi. So it's basically just as simple as a plug and chug, right? So formula, plug and chug. So you'll see that a lot at the end of this year. Okay, next one. The arc length of an arc is 10 pi yards. Find the radius of the circle. So now we're given the arc length is 10 pi yards. Okay. We're going to need a central angle, so that's unfortunate, but we'll just say that the central angle is 60 degrees. We want to find the radius, okay? So, again, I got my formula. Arc length is x over 360 times 2 pi r. That equals 60 over 360. Okay, times 2 pi r. Now this will simplify to give us 10 pi equals 1/6 times 2 pi r. So 10 pi equals 1/3 pi r. We multiply by 3, we get 30 pi equals pi r. Divide by pi, and we get 30 equals r, 30 yards. So again, I'm just plugging into a formula. Okay, it's just formula work to find that. Okay, so I was trying to find the radius in that problem. Okay, so my apologies, I didn't give you a central angle. Okay. All right, so next one, same idea, right? It says find the length of the arc subtended by the 60-degree angle shown. So subtended just means, you know, like, that's where to look for the angle, in a sense. It's not the technical definition, but, so again, we want to find arc length. L equals x over 2 pi r, or sorry, x over 360 times 2 pi r, right? So we're trying to find this length of this arc in linear units. Okay, so not in degrees, right? We know how to do it in degrees. It's just a measure of the central angle. So the arc, it is 60 degrees in degrees, but we want to figure it out in linear units. So we're going to plug in L, 60 is our central angle, times 2 pi times 12. And again, this will give us 1/6 times 24 pi. That gives us 4 pi centimeters. So again, notice I'm not using a calculator. There's no need to use a calculator for some of these. You can just leave your answers as pi. Example 5, obviously, it looks pretty crazy. And you could plug it into a calculator if you really want to figure out, you know, what that number is. But for most of them, you can just figure out, you know, let's use the formula, right? And the formula's right there. So that's the circumference. And this is some, you know, fraction of the circle, in a sense. Okay, so last part we want to look at is, now notice all the angles were in degrees here, right? We have x degrees, 130 degrees, right? 60 degrees and 60 degrees, right? So in this formula is always for an angle in degrees, but what happens if an angle is in radians? So remember on your calculator, there's that but, RAD, radians. And radians is just another way to measure an angle. So it's degrees and radian. So it's more like inches and feet in a sense that you use them both to measure something, but just in different contexts, okay? So radians is used with this Greek letter theta, which is listed right there. Okay, theta is a Greek letter. There's plenty of Greek letters. You can look them up. Alpha, beta, gamma, delta, epsilon, you know, omega, upsilon, omicron, pi, mu, nu, psi. Okay, so there's plenty of them. You can look that up. But in math, we do use Greek letters quite frequently. So, and as I've written here, right, radians sound a lot like radius. So yeah, we are just measuring, it's a different way to measure, right? Instead of degrees, you're using the radius basically to measure the length of the circle, okay? So remember the arc length formula is right here. Now, remember we're using theta. Theta is what the angle we use for radians. Now, 360, you're just going to have to trust me on this one, that 360 degrees in radians is 2 pi, okay? So that's just a fact. I can show you in a minute why that's true. Multiply by 2 pi r, these cancel. So the formula to find an arc length with an angle in radians is arc length equals theta times r, or arc length equals r times theta. So this is the formula to find arc length if your angle has pi in it, or radians. If they tell you it's in radians, you can use that one too. So this formula used to find arc length for an angle in degrees. Okay? So there's two different formulas, okay? But you can convert from degrees to radians and radians to degrees. So let's say you really like this formula right here that I've highlighted in orange. Let's say, Mr. Enzi, I don't like degrees. That other formula looks too complicated. This one's better. Well, there's a way to convert from degrees to radians, okay? So what you can do is you can multiply your degree measure by pi over 180. So let's see how to do that. So if you wanted to convert 30 degrees to radians, right, to have pi in it, you just multiply by pi over 180. So we do 30 times pi over 180. And no, you definitely don't plug these into a calculator, okay? That completely defeats the purpose of this. So you get pi over 6. So pi over 6 radians is equal to 30 degrees. So it just depends on what you want. Now, radians is heavily used in trig, okay? So in trig class, so trigonometry, okay? So knowing which angle is what being able to convert is definitely a skill you want to have coming up in a few years, okay? All right. Now, if you wanted to go from radians to degrees, if you wanted to go backwards, basically, so you multiply your radian measure by 180 over pi. So, for example, it says convert pi over 2 radians to degrees. So if I did pi over 2, and I multiply that by 180 over pi, the pi's cancel, and I get 90 degrees. So that tells us that 90 degrees is equal to pi over 2 radians. So those are the same thing. It's just a different way to measure the angle, okay? So you can measure angles in degrees, or you can measure them in radians. And again, radians means that it has pi in it, okay? So how do we find the arc length if an angle is in radians? Well, it's pretty simple, right? It's that formula right there that I highlighted. So if you want to find the arc length of zy, right, zy is right here, we want to find how long it is, right? So again, we'll use our formula. Arc length equals radius times theta. So the arc length is equal to radius is 9, theta is 3 pi over 4, and we get 27 pi over 4 centimeters. That's it. So, no tricks here, right? Okay. Now the next one, example 111. Okay, why don't you try? Okay, so again, right, the formula is arc length is equal to the radius times theta. So arc length equals 5 times 3 pi over 7. And we get 15 pi over 7 centimeters. And that is the arc length from point Z to point Y. So yes, you could plug that into a calculator, right? You get like 45 or 47 over 7 or something. So it's about 6 centimeters. Yeah, something like that, you know, in the general region, 6.5. Okay? All right, so last one, find the radius of a circle if the length of arc DE is pi over 6 radians, and the central angle measures pi over 3 radians. So again, now if we want to find the radius, now the angle is in radians, right? So that's where we're going to use the arc length equals radius times theta. So again, we're just going to plug and chug. Pi over 6 equals radius, which we're trying to find, times pi over 3. Now again, you need to solve for r. So again, you just do algebra 1. So I know people are going to get confused here. Remember, how do you solve for r? Well, you multiply by the reciprocal. We need to get that pi over 3 out of here. So we're going to multiply by 3 over pi on both sides. Right? Because the 3's cancel, the pi's cancel. So we'll get, the pi's cancel, we'll get 3 over 6 equals r. So 1/2 equals r. So 1/2. And, you know, maybe it's in meters. I don't know. Who knows what units we're using? Probably better actually just to say 1/2 units. Okay. Now, maybe you're asking, Mr. Anzi, I'm not a dummy. I can tell that the arc length is you know, is double the central angle. And that's true. So I could definitely see that. Okay. So that's pretty much it here. Okay. You're just basically plugging and chugging into formulas. Okay. So again, one last comment, right? Radians in degrees are both measures of angles. If you want to find the arc length for an angle in radians, use this formula. If you want to find the arc length of an angle in degrees, you're going to use this formula right here. Okay? And again, the arc length is just how far it is from one point on the arc to another point. All right? Okay, so that's it. Have a great day.